Now the topic is representation of binary tree. There are two representation. One is array representation and second one is linked representation. Let us start with array representation. Let us look at array representation of binary tree. I have an example binary tree here. Labels are alphabets, so that's easy for you to understand. Also, I have an array, and one thing is array index is starting from 1 onwards. But in C++, array indices start from 0 onwards. So for storing in C++, we can ignore the index 0. If at all you want to use that also, we will see it afterwards. So right now, array indexes start from 1 onwards. Now how to store this binary tree? For storing a binary tree, I have to store two things. First one is all the elements, that is A to G, and the relationship between those elements. Like A is a parent of B and C, or B is a left child of A, C is a right child of A. Likewise, B and C are also having their children. So if we are maintaining parent and child relationship, then we can produce a tree back again. So just storing the elements will not be sufficient. We should also preserve their relationship. How I can do this? Elements, I can store them in these spaces. Yes, it's okay. But how to maintain the relationship? Maybe this indices may help me. The index of each location can help me to preserve the relationship. Yes, I will use that. How? I will show you. So first of all, I will fill the elements. Then I will show you how they are maintaining the relationship. I will store these elements level by level. So the first level element is A. The next level, second level, B and C. So okay, I will store B and C. Then third level, D, E, F, G. So D, E, F, G. I have stored all the elements. Now I have to see whether the relationships are preserved or not. Let us observe the indices. Here I will prepare the table of indices. With that you can understand. See, the first element is A. A. What is the index of this element? 1. Then who is the left child of A? B. Where is B? At 2. Okay, it is at 2. Then who is the right child of A? C. So what is the index of C? 3. So right child index is 3. Then next I'll take element B. What is the index of B? 2. Left and right child D, E. Where is D? 4. And right child E is at 5. Then let us take C. C. It is at index 3 here. The index of this element. Then who is the left child of C? F. Where it is? 6. Then who is the right child of C? G. Where it is? At 7. So I think this is sufficient to understand how the relationships are maintained with the help of indices. See, when an element is at index 1, then its left child is at 2 and right child is at 3. If the element is at index 2, then left child is at 4 and right child 5. So 2 into 2, right, 4. So 2 into 2 plus 1, 5. 2 threes, 6. 2 threes plus 1, 7. So yes, this is the formula maintained. If any element is at index I, then its left child is at index 2i and right child it is at index 2i plus 1. So elements are stored based on this formula, right? If any element is at index I, then its left child is at index 2i. Then right child is at index 2i plus 1. So these are the formulas used. Now one more thing. If I take any element, then where is its parent? Like for example, F. Who is the parent of F? C. So F is at 6, C is at 3. So when this left child we are getting it by multiplying it by 2. So parent we will get it by dividing it by 2. So the parent of any node will be at I by 2. When you divide any number by 2, you may get a decimal result. So shall we take it or not? Let us check. G is a child of C. G is at 7. Where is its parent? At 3. So this is 7 by 2 is a 3.5. So we should take the floor value, that is 3. So yes, this is floor value. So for any node, these formulas will help us to obtain its left child, right child or parent. Now, when I was filling these elements, I did not follow this formula. I just fill them level by level. And automatically those formulas are applied. Yes. So for filling it, either you follow the formula or fill them level by level. Automatically that formula will be followed. So that's it. This is the array representation of binary tree. Now I will take few more special cases.